Lesson 5.1, Verifying Trigonometric Identities. So first of all, it's important to remember the Pythagorean identity sine squared x plus cosine squared x equals 1. We can also rewrite this identity by solving for the sine squared of x. So if you subtract both sides of that equation by cosine squared x, you get an equivalent identity. Sine squared x is equal to 1 minus the cosine squared x. You could also take that same identity and solve for cosine squared x. And you would get cosine squared x equals 1 minus the sine squared x. Verifying trigonometric identities is all about showing your work. So if we want to verify an identity like cosecant x times tangent x equals secant x, what you want to do is start with the left-hand side of the equation and rewrite it. So I just rewrite the left-hand side of the equation. But I'm not going to rewrite secant x until the very end. So I'm going to start with this, and I'm going to replace what I know here with equivalent things. So for example, the cosecant of x is the same as the reciprocal of the sine of x. The tangent of x is the same as the sine of x over the cosine of x. So all I did is I replaced this with what it is equivalent to. I replaced the tangent of x with what it is equivalent to, then I need to do a little math. When I multiply fractions, I normally multiply the numerators, multiply the denominators, but the sine of x is going to cancel the sine of x, and that's how I'm going to be left with 1 over the cosine of x. But the reciprocal of the cosine of x is equal to the secant of x. And so at the very end, you should get this. The next identity, cosine x cotangent x plus sine x is equal to the cosecant of x. I want to rewrite the left side of the equation all by itself first. So I just rewrite it. Then I want to start replacing things that I know. So for example, I know the cotangent is equal to cosine over sine. So that's what I'm going to do. That's my next step that I'm going to show. So this cosine comes from here. The sine, I'm not going to do anything with that, but what I did is I replaced cotangent with cosine of x over sine of x. Then I multiply this together. This is like over 1. So I multiply it into the numerator, and that's equal to the cosine squared of x over the sine of x plus the sine of x. So I just bring that down here. Now, when I add fractions, I've got to get a common denominator. So that's what I'm going to do. I'm going to turn this into a fraction with a denominator sine of x by multiplying top and bottom by the sine of x. And so this is like over 1. And when I multiply top and bottom by the sine of x, I get sine squared x over sine of x. Once my denominators match, I can add the numerators. So that's the next step that I'm going to show. I just add the two numerators, and so it's all over the sine of x. But using the Pythagorean theorem identity, sine squared x plus cosine squared x equals 1, doesn't matter if I write it in a different order, cosine squared x plus sine squared x, that is equal to 1. So I have 1 over the sine of x, and I know that 1 over the sine of x, the reciprocal of the sine of x, is the cosecant of x. So I'm done as soon as I get to the right-hand side of the equation, as soon as I prove this.